Hey everybody, welcome back to the channel. Palantir just had their Apollo demo day, and it is time to break down and understand a little bit more about Apollo. Now, it wasn't really a demo day in terms of like 3 hours long in this presentation or anything, but it was more so an 18-minute video that they premiered on the channel. The reason they called it a demo day, I think, was to do a little bit of marketing, a little bit of clickbait on Palantir to get people into the door, but nonetheless, they did a good demo day. And it was an 18-minute video of them really explaining how Palantir and the Apollo product operates. So we're going to watch a little bit, around 5 to 6 minutes, of the chief architect of Palantir Apollo, Greg DeArment, I believe is how you say his name, talk about it. I'm going to give me a reaction. I'm going to give my thoughts. And ultimately, the chatter that I've been hearing around this concept is that Apollo can expand Palantir's TAM massively. And if they're able to expand Palantir's TAM massively, because it's not just like a software as a service that they provide, but it's an underlying foundational structure to how companies ship software through their organization. We're going to talk about what that means in a second. Then it's something that can be pretty big. I also want to give a shout out to CodeStrap. I'm going to put a video in the description. He did an interview with the guy we're about to watch, which is just amazing that Palantir let him interview him and ask him all these questions. So definitely recommend checking out that interview and getting some of your thoughts on Palantir's Apollo. So let's get into it right now. Here we go. Palantir Apollo's demo day.
Microservices and service-oriented architectures have become so popular because the promise of faster innovation through distributed work. But in order for you to actually realize these benefits, the teams need to be able to actually evolve at different speeds. Teams should be able to ship new features and capabilities as soon as they're ready, instead of having to be slowed down and wait for a weekly, monthly, or quarterly release schedule that is determined by the slowest mover or your ability to QA the platform. In a service-oriented architecture, there are just going to be API dependencies between the different services, but you want those to be able to ship new releases at different rates. So
what he's saying here is that there's interchangeable levels to an organization. And when he says ship, he means software updates throughout an organization or throughout the product. So if you have a product that you're trying to shift a software update to, before you shift that software update to, let's just take YouTube as an example. You can't ship a new user interface design on YouTube unless it makes sense with all the other user experience features on YouTube, right? So if YouTube finds a new way to display comments, but it doesn't really make sense because when people play a video and they close the video down, then there's comments up and it's like this really weird experience that they have with the new user interface of comments, then it doesn't necessarily make sense. So the engineers at YouTube have to really figure out how to make sure on the beta version of YouTube before it goes live, when they ship software, how that software interacts with a lot of the different other moving parts of software within a team internally and within an organization internally before it goes out to the public. So what I believe Greg is talking about here is that there's a lot of different architectures that exist and APIs that exist that need to be able to communicate with each other as we're creating new software updates into a product in order to get it to consumers or to clients. And the way that we communicate through that can be built on a platform that is Apollo. It can be built in a way that makes it cohesive and makes sense for an organization to use.
From the very beginning, Apollo was built to address these intrinsic problems that come with distributed systems by allowing the software engineer teams to encode the preconditions and the expectations of their software next to the code itself. Apollo then takes these embedded constraints and ensures that they aren't violated in the act of upgrading, and makes it possible to safely automate rollback of a given service without causing an impact to the availability of the entire platform.
Okay, so that's a big deal, right? So for example, you ship the new YouTube comments user interface design and that messes up how the video is enacting or whatever for the user experience. Apollo is this thing that says, here's how you ship it in a way that doesn't screw all over everything. Here's how you can get it back. Here's how you can interact. Here's how we have the distributed code on these systems interact with the source code on these systems, and they all interact seamlessly. And if there's ever an issue, because Apollo is the thing that's distributing it based on what Palantir's innovated with this product, you're able to roll it back, you're able to enhance it, you're able to get rid of it, you're able to have systems that protect different elements of the code. It's like this all-in-one service for companies that need to be able to shift software updates in a way that doesn't screw them over, which seems to be a big issue in very, very high technical industries and a majority of companies that are actually shipping lots of code for lots of products.
At compile time, storage systems are able to declare the set of schemas that they are able to read from and write to, specific migration steps they support, and a way for the current version of their schemas to be reported at runtime. This makes it possible for Apollo to safely upgrade storage services through schema migrations and roll back when necessary with safety rails that prevent data corruption. For the second principle, a software developer shouldn't need an in-depth understanding of the environment or infrastructure system that their software will be run in order to build capabilities that power world-class software. When the world was building and shipping software monoliths and deploying them to one or two virtual machines or servers, the hardest deployment problem that developers faced was trying to understand Linux. But today, the infrastructure that software is being built on is far more complicated, and it's only becoming more so. With that being said, the infrastructure systems available today make it possible to provide the non-negotiable capabilities of modern software. Things like data encryption and network security, software that is highly available and can be updated without user downtime, and the ability to deploy across multiple cloud providers and to the edge. These are all increasingly crucial for business-critical software.
So a lot of those elements are just phenomenal. I mean, let's go back to them just a little bit right here. Data encryption, network security, multi-cloud, edge. I forgot what HA stands for, but like, man, I mean, like if developers don't need to understand the infrastructure or the complexities of code that they're not native to working with, meaning they can work in an environment where, because it's distributed through Apollo, they can understand things in a more meaningful way. It does release the burden, I would assume, of just the team working together to try to ship out updates, which makes things easier for people.
For a developer to build and deploy a modern Java or Python application that needs to be highly available, maybe it needs some configuration, it needs certificates to serve HTTPS traffic, and exposed through a front door proxy, they would need to understand, configure, and maintain 6 or 7 different Kubernetes objects in addition to the cloud infrastructure components that expose that, like network load balancers. That just isn't a good use of most developers' time. So Apollo provides an SDK that developers can use to build modern software applications. Apollo's SDK allows the developer to declare the properties of their software, like, maybe I need a local persistent volume, or I need 3 replicas of my service, and quorum for my service is having any replica be available. Apollo can then generate and manage the appropriate Kubernetes pod controllers based on those declared properties. A certificate and the corresponding public and private keys are generated and provided to the service so the service can configure TLS encryption for HTTPS traffic without needing to understand how PKI material is created or managed by the platform. And the developer is able to declare that their service produces an API endpoint and request that that endpoint get exposed over a reverse proxy at a certain path.
Now, a lot of this may seem complicated, and it's definitely complicated for me as well. I'm not going to pretend that I understand every last detail of what he's saying. But at its core level, if you want to get something out of this, what I'm understanding is that things are encrypted. Developers understand how they're encrypting certain pieces of software. And when they're using Apollo to be able to do the facilitation of the distribution of certain updates or other things that they're trying to get into the code, it all starts to make sense to them because of this sort of end-to-end encrypted, protected layer of software that goes in, it goes out, it gives you they're working on distributed systems. So when you're not working just in one place and there's a lot of different moving parts, you need something to be able to make sense of all those moving parts. And that's what Apollo seems to be doing to me. And the question is how much business impact can this have? And already the idea of that in and of itself, it's hard to wrap your head around. Like, you can get Foundry, you can get Gotham. It's like, what is this thing? But this to me is 0 to 1. I mean, this to me is absolutely 0 to 1. Like, what other company is doing something like this? The fact that you can't even fully understand what they're doing goes to show you that, like, maybe there's not that much competition for this. Maybe this is actually something that they've created in and of themselves. It's one of the things they're finally starting to talk about because they have not talked about this as much as the other things. And we'll see ultimately how this goes for a business sense.
All without needing to understand the complexities of the way Kubernetes cluster ingress system is set up or how ingress objects work. All of these capabilities are possible without making a single line of code change. The third principle is making it possible to deploy software where it is needed by enabling software platforms to be repeatable, reproducible, and portable across cloud providers and infrastructure types. For example, many companies may find the idea of delivering their software into a new environment daunting, as their platform is nearly impossible to set up from scratch, much less operate multiple installations of at once. Others have deployment pipelines that are highly tailored to a single environment, where introducing a new production environment would fundamentally break their existing deployment process. Market access just isn't an obtainable goal for many, because technology and tooling used to deliver the software has been designed for the single SaaS environment paradigm.
What he seems to be describing is how complex it is to actually get software from, as you can see, Team A, Team E, Team B, Team C, all the way down to the endpoint where it needs to go. And he's saying the current paradigm is very unidimensional, and Apollo sort of brings something new to this.
And as the world has evolved, their tooling has not. So Apollo takes a very different approach than other tools in the DevOps or platform engineering space. Apollo starts by modeling software you want to run across your environments and enterprise into a single software catalog. This allows all parties to share a single view of everything that is known about a piece of software, from what is declared by the developers, things like cross-service dependencies, supported schema versions, resource requests, and so forth, to information that is augmented by external systems like virus scanners or vulnerability scanners, or the security scanners that you're already using across your enterprise. Different software platforms can then be defined as the composition of the individual services and products that exist in the Apollo catalog. Apollo then models each environment that you want to deploy and manage software into and declare a set of entities, unique installations of a given software product from the catalog. Release channels are used to represent the different stages software progresses through as it rolls out across your environments. Release channels allow you to model non-linear rollout processes. If your business model is more like Palantir's, it requires you to manage a large number of environments and deploy your software to where your customers are. You may choose to use release channels to model confidence of new releases, where you first deploy your software to canary environments before rolling it out to more mission-critical environments that are more risk-averse. This approach to software rollout avoids the most painful failure modes of traditional pipeline-driven continuous deployment models, where pipelines tend to be specific to a single or small set of services and evolve in silos along team boundaries. Release channels provide a consistent approach for your production management story across teams while still allowing each dev team to control the inputs to the system that dictate how their software gets rolled out. And the final principle,
from that, the what I'm understanding from that is that there's more autonomy for developers. Like the current paradigm that exists in organizations has not evolved for this unidimensional approach of how we distribute software. Again, I don't understand everything technical that's going on there, but what I do understand is developers have more autonomy based upon using Apollo to determine the basis by which they actually enact and encode their software into a distributed system in order to get an update done. And from a developer perspective, I know CodeStrap says that is incredibly important. Like that type of, distributed system and autonomy for developers has not existed before, which is phenomenal. And from a regular person trying to understand that, we might not get it. We might not be like, all right, what's the big deal? But from a developer, and this is why the technical community, the developer community is incredibly important for Palantir. If you're able to build that out and developers are able to get a hold of that, they will evangelize this product and call for it in their own companies, which is what I believe, even CodeStrap has said he's tried to get done in his own organization. Because when you see the power of this, you start to get people to realize we need this thing because we're going to be faster, more effective, more efficient, all that stuff in here. So let's go through the fourth one. But I mean, at the end of the day, this is seeming like something that truly can be monumental and different. And the whole world doesn't know about it. The only people that know about it are the people watching this stuff and are ready to at least take a risk of understanding what it could be 5-10 years from now.
Effectively managing software in production extends beyond the simple act of deploying a piece of software and depends on the active collaboration of software developers, operators, security, and compliance teams. If we've learned anything over the last few years, software supply chain security and related problems are not going away. In the same way that we don't need every engineer understanding the details of the infrastructure their software runs on, we also don't need them spending time becoming experts in how software security works. It should be an integrated part of the production management story, and it should come for free. With Apollo, the software catalog becomes a central gate that governs what software can and cannot be deployed into production, based on the policies determined by the security and compliance teams, without impeding on the natural software development process. It integrates with your existing DevOps toolchain, like your continuous integration system, your artifact and container registries, and your vulnerability and security scanners. Your security teams can define vulnerability policies that enable Apollo to automatically recall releases that violate those policies, or notify the security team where there are releases that are out of compliance for prompt annual review. Post-software deploy, Apollo will continuously check the health of each of the software installations if the development team opted into the health system. This allows developers to encode SLOs and other criteria that their software should meet in order for it to be considered healthy. Additionally, they can also declare how their software should be monitored within the software artifact itself, making it possible to define the expected behavior without having to modify the code. Apollo aggregates. All
right, so to me, we're going to end it there, but that screams developer autonomy to me in terms of the developers actually being able to figure out what to do with their software and how they want to distribute the software at scale. So if we go to CodeStrap right here, he did a interview right here, Greg Yarman interview, Apollo Chief Architect. I have not fully watched this yet. As you can see, I'm 17 minutes in, but I mean, it's high level stuff at the end of the day. Now, and I want to just take a second to acknowledge that Apollo is one of the most complex things that I've ever heard of before. And it's really exciting for me to be an investor in a company that is this complex and doing something this intense, because some people will brush it off and saying, oh, they're just fancy marketing a basic, business intelligence system at the end of the day, which is what a lot of people say to me on Twitter. And to me, I'm like, Snowflake's not doing this. Like, this is not just happening that easily from some of these other companies. Like, this seems like a very integrated, intense approach that highlights the ontology, which if you're a Palantir shareholder, you understand what that means. It is a central operating system that allows you to make sense of something at such a deep level that it provides insights that are fundamentally different because the way you facilitate the frameworks to achieve those insights are fundamentally different. That's what Apollo screams to me. And even though I don't fully get it technically, and I'm sure 95% of people watching this don't fully get it technically because it's a hard thing to understand, which is why Palantir is like kind of a hard business to form a cult around because it's like hard to understand. But it's also easy to recognize that if it's hard to understand, that means there's something there. Tesla, it's a car. All right, we get it. It's easy to understand. Palantir, when you're talking about software, and software that's this complex to the point where they're stopping terrorists, right? Like, this is the type of company that you're investing in. It forces you to just recognize there is a complexity to this, and there's a reason why there's a complexity, and maybe I should go deeper into why there's a complexity. It's the same thing with Bitcoin and Ethereum. If you didn't understand what decentralized currencies and financial systems were back in 2016, 2015, you wouldn't have invested, and you wouldn't have got the crazy run up from crypto, which I didn't either because I didn't know about this stuff in 2015, 2016. I didn't care to think about what a blockchain is. Like, a blockchain is a totally whole new way of using the internet. And, if you missed out on it, then you missed out on this initial run. Now, can cryptos go up more? Maybe. But the point is, it's incredibly important to at least take these things seriously is what I'm trying to say. You don't have to agree with it. You don't have to feel like, oh, it's the next best thing since sliced bread. But when a company that is run by a particular leadership is trying to innovate a new form of software and they have a hard time communicating it to the masses, it's not because they're the worst communicators. I mean, yes, you can make the communication a little bit better, but it's because there's actually something deeper going on that is difficult to just get people to understand. Just like if you were trying to get people to understand the blockchain, or you were trying to get people to understand electric cars way back when, before Tesla even became a thing. So as a result of that, for me, as someone who understands Palantir and wants to understand them more, it just means I have to go deeper into this product and understand a little bit more about it, and understand why they are trying to innovate in this space in particular, this distributed system software space. Why are they trying to get this done? Why does developer autonomy matter this much? And CodeStrap's done a great job breaking this down as well, and you can get insights from him. But at the end of the day, if you don't do the reading, if you don't really go through the website, if you don't read other articles that they're citing, that they've been able, if you don't know what Kubernetes is, which I don't fully understand as well, then you're not fully going to get it. That doesn't mean you can't invest in it, but that also means you're not going to fully get it. And if you're curious, then it makes sense to go a little bit deeper and try to fully get it at the end of the day. And I hope as I'm on that journey, I'll be able to provide you guys that content over time. So thank you guys so much for watching. Let me know your thoughts on Apollo. Obviously, it's something very unique and it's very different, but we'll see how it plays out and how it helps them from a business perspective. Thank you guys so much for watching. Let me know your thoughts on Apollo. I'll see you in the next one.